I'm a voltage spike. 10,000 houses in Livermore just turned on the AC, so the utility has to switch power across the grid. When I throw this switch, it's going to send a transient spike like me across the entire local grid. If you have cut rate input protection, it can kill your VFDs, stopping production dead in its tracks.
Today's Rockwell drives have a failure rate of less than 0.5%. Of those failures, the vast majority are environmental in nature, usually related to heat. But the next most common failure mode involves electrical disturbances of the power grid. Spikes and sags in utility power are all too common as we get our electricity from an aging grid that's not designed to handle today's demand. Utilities these days aren't building enough substations to accommodate our current needs, so they have to regularly shift power from one area to another. Every time they open one switch and close another, they send a microsecond high voltage transient across the grid, which can damage electronic equipment. These transients happen so quickly that you can't monitor them with standard voltage meters, but using ultra-sensitive equipment we can see them, and we see their effects simultaneously in facilities of our customers, who lose VFDs and face downtime in the equipment they control. In the old days, you'd start your motor across the line with a combination starter. These are rugged devices that can easily withstand line disturbances. But modern facilities rely on the ability to vary the speed of their machinery to make production more efficient and more profitable. And mandates to become more energy efficient have put VFDs in control of more and more motors, placing them in jeopardy from line power issues. Modern VFDs have some form of input protection in the form of metal oxide varistors, or MOVs. These devices can react to voltage surges and protect circuits downstream. They can absorb some transients, but they become less effective each time they take a hit. Also, many of our drives have a DC bus choke. That helps protect the main capacitors in the drive from spikes and sags. Both of these features are helpful, but as drives become more microprocessor-based and smaller in size, it's increasingly difficult to build in protective devices to handle transients in high-voltage three-phase systems. How can you protect your important investment? Well, in the fine print of every drive manufacturer's manual, you'll see a recommendation that if your facility's transformer is greater than 10 times the kVA of the drive, you should use some form of external input protection, usually a line reactor. A line reactor is nothing more than an inductor that absorbs a portion of these transients, slowing the rise time of the spike and keeping the drive behind it safe. Compared to the drives they protect, they are relatively inexpensive, and one of the great things about a reactor is that one of them can protect several drives in an installation. Line reactors can also help reduce harmonics in an electrical system that are caused by a VFD's irregular sine wave. And if you put them on the output side, they can help protect motors from damage caused by reflected wave spikes over long cable runs. Generally speaking, it's wise to spend a few $100s to protect a drive or multiple drives costing thousands of dollars, not to mention the costs associated with downtime and loss of production. We call them cheap insurance. At Buckle Smith, we represent multiple manufacturers and types of input protection. Talk to your account manager or technical specialist and we'll help you choose the solution that's right for you.
So get a line reactor. It's cheap insurance to protect you from mayhem, like me.